Alright, in this lab we're going to focus on similar triangles, and we're going to look at how are two triangles related if they have the same shape but different sizes. So you had an activity to look at to get started in this lesson. It's a similar picture, but it was all about Ariel's view from outside of her window and looking at what the relationship between the two triangles were. So hopefully you answer that question to kind of get yourself thinking about what that relationship is when you find a triangle within a triangle like that. And you have a similar picture here on this screen where you see a triangle inside a triangle where the triangle is sharing two of the sides. The inside triangle is sharing two of the sides. So we're going to kind of go through a similar activity, this hands-on activity, to look at what happens when you have a triangle inside a triangle. So we're going to determine if there is a relationship between the two triangles similar to this diagram that we see below. So in this diagram we just have it written out with the lines, and so basically you have your three parallel lines and a few transversals going through. So line LR, which is the line at the top, line MN, the one in the middle, and PQ, the one at the bottom. They're all parallel to each other. You can see that's written there with the bars. And then line LP and LQ, the lines that cross through, are your transversals. So if we were to go through and actually take this activity, take that picture and measure, we're going to actually do that. So that's not something that I'm expecting you to do with your own ruler or like you can see your protractor. But if we were to measure these and go through, we're going to look at some of getting my pen here, some of the things that we can notice about the relationship here. So we're going to measure and record the length. So basically I'm going to go through and tell you some of the measurements here. We're going to look at some of the similarities that we see. So the first triangle is triangle LPQ, which would be this triangle here, the big triangle. LPQ, side LP, is actually 18 millimeters. LQ is 21 millimeters, and PQ is 25 millimeters. The other triangle, LMN, the smaller one that's drawn inside here, let's go through those segments. So side LM, which shares part of LP, is 9 millimeters. LN, which shares part of LQ, is 10.5 millimeters. And then MN, which would be the bottom of the triangle like PQ is 12.5 millimeters. So that's the side lengths of each triangle. Now let's look at the angle measures. So the angle measure of angle L at the top, the very top point, is 78 degrees. And that's the angle that's actually shared in both triangles. So it's 78 degrees for measure of angle L in the big triangle and for the one in the small triangle. So I'm going to fill that out now since we have both of those angles are shared. Now to jump back to the big triangle LPQ. The measure of angle P down here in the bottom left corner is 58 degrees. The measure of angle Q is this bottom right angle is 44 degrees. So if we were to use a protractor to measure the angles, this is what we would find. And then when we jump to the small triangle, the measure of angle M is 58 degrees. And the measure of angle N, the bottom right angle on the green triangle, is 44 degrees. Now let's look at the measurements that were given. Let's compare the side lengths and the angle measures in both triangles. What do you notice about them? What do you notice about the side lengths? What do you notice about the angle measures? Take just a few seconds to read through and look at those side lengths and where they're placed on the triangles and how they're related. So what do you notice about the measure of the corresponding angles of the triangles? hopefully you saw that all the measure angles, the ones that correspond to each other, are equal. Okay, so the measures are equal. The measures of the angles are actually equal. So measure of angle L was the same because that was the same angle. But then when we looked at angle P and M, those would both be the bottom left angles and they're the same measure. And Q and N are the bottom right angles and they're the same measure as well. So now that we see they're not the same size, they're the same shape, but they do have equal measures of angles. So now let's take a look at, scroll down to the last part here. Let's take a look at our side lengths. Now the side lengths, to compare those, we're going to set up some ratios here. So let's set up the ratios of the angle measures, and I'll pull the ones that we had up here again in a second. But if we were to write those, we would set them up as basically a fraction as a ratio. So LP was 18, LM was 9, LQ was 21, LN was 10.5, PQ was 25, and then MN was 12.5. Now if you were to simplify all of these and reduce them down, divide them and simplify them out, we'd actually get 18 divided by 9 is 2, 21 divided by 10.5 is 2, and 25 divided by 12.5 is 2. So you can see we just made sure that we set up the ratios so that the side lengths from the large triangle on top and the small triangle on the bottom, so that we weren't doing a large triangle on top and a large triangle on the bottom. We kept the side lengths in the same spots in each ratio. So what do you notice about these ratios? The side lengths aren't the same, but we know they're not the same size, so that doesn't surprise us. That shouldn't be surprising. So what we're really looking at is, what do we notice about their ratios when we're comparing these corresponding sides? So take a second and see what you see there. Okay, so let's take a look at what we notice here. So when you plug all that information in, the ratios are also equal. So again, we know we don't have the same size triangles. We could see that from the pictures, but the ratios are equal. So we are finding out some interesting things about these triangles. So we've seen that they have equal angle measures and equal ratios of the corresponding sides, but not necessarily obviously the same shape. So we're going to go through and take a look at some more questions. You're going to be guided through some more questions in your assignment. We're going to look at a few things there. Basically, when we're looking at our similar triangles, the two triangles that we're going to go over from the activity and the triangles that we'll look at in the next spot, let's take a look at those now actually. Okay, so if we look at, you're going to be doing some of these questions here. So let's take a look at the investigate questions on the next page. So if you look at this, we have triangle ABC and then we have the angle A is 53 degrees. So I'm just going to actually finish drawing this triangle to show you what this triangle is going to look like. So if I were to finish this, angle X is going to be 53 degrees. But if we were to finish this one way, we're going to draw and label a different right triangle. So we're just going to draw a right triangle. There we go, that finishes it. And you could have stopped the row before, the row before that. It still would have been different, but I'm just going to label it X, Y, Z. So again, we see here that they appear to be the same shape, but again, not the same size. So we're going to look at some of those other things there. Now, the triangle that we looked at in the previous activity and the triangle in this exercise are actually called similar triangles. So that's what you're going to be focusing on as you go through another, some other measurements of the triangles that we just drew here. So you're going to go through and answer some questions based on the triangles that we have here in the picture, and you're going to look at those and then look at what that means for similar triangles. So if you have any other questions or need some help with that, make sure you let me know. You can come to office hours and go through the examples in the textbook. You can use those pages that are listed in the lesson above this.